Here we have a cuboid, A, B, C, D, E, F, G, H, and we are asked to find the length of the diagonal CE. So from C to E. To find CE, we can draw a right angle triangle. So CE, EG, and CG will form a right-angled triangle. So this is a right-angled triangle in the middle of our cuboid. We know the length CG is 5 centimeters. We've been given that, but we haven't been given EG. But EG is in another right-angled triangle. So EHG EHG forms another right-angled triangle. So we have 8 centimeters for EH and 4 centimeters for GH. So we can find EG using Pythagoras. So A squared plus B squared equals C squared. If we call EG X for now, we'll have, so X is the hypotenuse, EG is the hypotenuse. So the sum of the squares of the two shorter sides is equal to the square of EG. So we've got 4 squared plus 8 squared equals X squared. 4 squared is 16. 8 squared is 64. And that's equal to X squared. 16 and 64 make 80. So we can say X is equal to the square root of 80. And I'm going to leave it in that form. Going to leave it as square root 80. So now we know what EG is. EG is root 80. So now we can use our second right angle triangle, the one we've drawn, to find the length of CE. So if we call CE Y for now, we can use Pythagoras again. So again, the sum of the squares of the two shorter sides will be equal to Y squared. So 5 squared plus root 80 squared. So root 80 squared. So if I've got root 80 and I square it, the square and the square root cancel out. So it's just going to be 80. So root 80 squared is 80, and that equals Y squared. 5 squared is 25. So 25 plus 80 equals Y squared. So it's 105 equals Y squared. So Y will be the square root of 105. So we could leave it as that, or if we wanted to type it into a calculator, square root 105, we will get 10.24695 and so on. So 10.2 centimeters to 1 decimal place. There was a quicker way of doing this. So you'll notice that we ended up with 80 here in our second triangle, and that was 4 squared plus 8 squared. So we could have gone straight to using all 3 dimensions. So from E to C was 8 along, 4 back, and 5 up. So we could have gone straight to Y squared equals 8 squared plus 4 squared plus 5 squared. So we could have used 3 dimensions. So all 3 dimensions. So Y would be the square root of 8 squared plus 4 squared plus 5 squared. So we could have done it in fewer steps and we would have got the same answer. Okay, one for you to try. So give this one a go. So it's the same question. A, B, C, D, E, F, G is a cuboid, and we're finding the diagonal C to E. So it's exactly the same question. So we can draw a right angle triangle in the air, draw a right angle triangle through the middle of the cuboid, or we could say, if we call this x, we could say x squared, it's 9 along, 3 back and 4 up. So it's 9 squared plus 3 squared plus 4 squared. So x is the square root of 9 squared plus 3 squared plus 4 squared. And if I type that into the calculator, I get root 106, or 10.3 centimeters to 1 decimal place. So we could have done this in 2 triangles. We could have said, let's find EG by doing 9 squared plus 3 squared, and then square rooting. So we would have got root 90, and then we could have done root 90 squared plus 4 squared equals x squared. So 90 and 16 make 106, and square rooted the answer, we would have got the same thing. Here we have another example. We have the same cuboid, but a different question. So find the size of angle CEG. So that's from C to E to G. So what is the angle we're looking for? C to E to G. So that's this angle here. And we've still got a right angle triangle. So we're going to use SOHCAHTOA to find the size of our angle. We know the length of CG, but we don't know another length. So we need to know 2 lengths on a right angle triangle to find an angle. And we can use the triangle EHG. So we use the right angle triangle EHG to find the length of EG. So just as we did before, we've got 8 centimeters and 4 centimeters, and we want to find the hypotenuse. So Pythagoras says a squared plus b squared equals c squared. So in this case, 4 squared plus 8 squared equals y squared. So the sum of the squares of the 2 shorter sides is equal to the square of the hypotenuse. 4 squared is 16. 8 squared is 64. 16 and 64 make 80. So y squared is 80, which makes our y root 80. So e to g is root 80. So now we can use SOHCAHTOA on our triangle CEG. So we've got a triangle CEG. So we've got e to g is root 80. C to g is 5. And we're finding the angle CEG. We're finding this angle here. So let's label the triangle. The hypotenuse is the longest side. The opposite is opposite our angle. And the adjacent is in between our angle and the right angle. So we're using A and O. H isn't in the question. So it's TOA. We're using the one with O and A in. We're not using the one with H in. The ones with H in. So it's TOA. And that says, TOA means tan with the angle, tan x equals the opposite over the adjacent. So tan x equals 5 over root 80. We want to find the angle. So to get tan away from x, we do the opposite of tan, which is arctan or shift tan. So x is arctan, shift tan 5 over root 80. So shift tan 5 over the square root of 80. And we get 29.2. And it's in degrees. 29.2 degrees to 1 decimal place. And one of these for you to try. So give this one a go. So again, the question is asking for angle CEG. So from C to E to G. So we've got a right angle triangle, CEG, we know C to G is 4 centimeters. We want to find the angle CEG. We don't have any other information yet, so we need to work out this length EG. So we can work out that length using Pythagoras on another right angle triangle, which is EGH. So G to H is 3 centimeters, E to H is 9 centimeters. So we can use Pythagoras to find E to G. So Pythagoras says a squared plus b squared equals c squared. So c is always the hypotenuse. 3 squared plus 9 squared is equal to x squared. 3 squared is 9. 9 squared is 81. So 9 and 81 make 90. So our length must be the square root of 90. So E to G is root 90. So we can use SOHCAHTOA now. We know two lengths. So we know the opposite and the adjacent. We don't know the hypotenuse. We're not trying to work it out. So we're using tan. We're using TOA, the one with O and A in it. So tan with the angle is equal to the opposite over the adjacent. The opposite's 4. The adjacent's the square root of 90. And to get the angle by itself, we do shift tan, arctan, and we type that into the calculator. So 4 over the square root of 90. And that's 22.9 degrees to 1 decimal place. And we've got one more example. This time, we are told the angle BEC is 30 degrees. We're still finding the size of angle BFC. So that's our diagonal B to F to C. So our unknown, the angle we're finding, is BFC. But this time, we're starting not knowing any of the lengths of our triangle. We don't know what C to F is. We don't know what C to B is. So we need to work both of them out. So to do that, we can use Pythagoras to find C to F. So we have our right angle triangle FEC. So we have F, E, and C. Got a right angle here. We know E to C is 5 centimeters, and F to E is 8 centimeters. So we can use Pythagoras to find F to C. So Pythagoras says a squared plus b squared equals c squared. So a squared plus b squared equals c squared. So 5 squared and 8 squared equals the hypotenuse squared. 5 squared is 25. 8 squared is 64. 25 and 64 make 89. So h squared is 89. So the hypotenuse is the square root of 89. So c to f is root 89. So that's one side of our triangle. Then we can use the triangle, another right angle triangle, BCE. So BCE. So BCE is a right angle. BEC is 30 degrees, we've been given that. And E to C is 5 centimeters. We want to find B to C. So I'll call that Y. The hypotenuse is the longest side. Opposite is opposite our angle. And the adjacent is in between the angle and the right angle. Again, we're not using the hypotenuse. We're using O and A. So it's TOA, it's tan. And that says tan with the angle, tan 30, is equal to the opposite, which is y, over the adjacent, which is 5. To get y by itself, we multiply both sides by 5. So y is equal to 5 times tan 30. So 5 times tan 30 is equal to 5 root 3 over 3. I'll leave that as it is. So 5 root 3 over 3. So that's B to C. Now we have enough information to find our angle. So we've got our right angle triangle BCF. So it was B, F and C. And we're finding the angle BFC. We worked out B to C was 5 root 3 over 3. And C to F was root 89. So again, we're not using the hypotenuse. We're using the opposite and the adjacent. So it's tan. And we have tan with the angle equals the opposite. So 5 root 3 over 3 over root 89 over the adjacent. 5 root 3 over 3 is the answer in our calculator. So we're going to use that. So we're going to do shift tan, our answer, over root 89, and that will give us our angle. So shift tan, answer, over the square root of 89, and we've got 17.0 degrees to 1 decimal place. And one of these for you to try, so give this a go. So again, we're calculating BFC. So B to F to C. So we've got a right angle triangle here. And we don't know any of the information, but we know BEC is 35 degrees. So we can use that to calculate BC, and we can use our two lengths, 9 and 10, to calculate FC. So let's calculate FC. So using Pythagoras, a squared plus b squared equals c squared. So 9 squared plus 10 squared equals h squared. 9 squared is 81. 10 squared is 100. So h squared is 181. So h is the square root of 181. So that's F to C. Then we can use SOHCAHTOA to find BC. So we've got the opposite and the adjacent. We're not using the hypotenuse, so it's going to be tan. So we've got tan with the angle, so tan 35 equals O over A, y over 10. So multiply both sides by 10. Multiply both sides by 10. So y is equal to 10 tan 35. So we've got 7.00. We're going to keep that in the calculator though. So we know our two lengths, so we can use that to calculate our angle. So I'm going to draw the triangle out again. It's getting messy. So we are calculating the angle X here. We know we've got root 181, a right angle here, and we've got 7.0, which is our answer in our calculator, over here. So we're not using the hypotenuse. We've got the opposite and the adjacent again. So it's tan. So tan with the angle, tan x, is equal to the opposite over the adjacent, which is our answer, over root 181. To get x by itself, we shift tan, so arctan, our answer, over root 181. So let's type that in, shift tan, answer, over root 181, and we get our answer of 27.5. It's degrees to 1 decimal place. So one question to finish up. We've got a square base pyramid with a base. The base length is 5 centimeters. And a perpendicular height of 20 centimeters. So find the size of angle EAC from E to A to C. So we've got a right angle triangle in the middle, so using the perpendicular height, a right angle triangle, so from the middle of AC, so AME, that's our right angle triangle. We know EM is 20 centimeters. We're finding this angle X here, and we don't know any other information, so we can work that out using Pythagoras. So if we use the triangle ADC, so it's a right angle triangle, it's half of a square, so ADC, A to D to C, we know we've got 5 centimeters and 5 centimeters. So we can find the length AC, and then if we want AM, we just half AC. So we'll call this H. So Pythagoras says the sum of the two shorter sides, the sum of the squares of the two shorter sides is equal to the square of the hypotenuse. So 5 squared plus 5 squared equals h squared. So 25 plus 25 equals h squared. So h squared is 50. So we can say h is root 50. So h is root 50, which means a to c is root 50. So a to m is half of root 50. So root 50 over 2. And now we've got our right angle triangle. So we know all the information that we need. So AME is our right angle triangle. So we have AME. We know it's 20 centimeters tall, and A to M is root 50 over 2. We're finding angle X. So we're going to use SOHCAHTOA. Let's label the triangle. We've got the hypotenuse is the longest side. Opposite is opposite the angle. And adjacent in between the angle and the right angle. So again, we're not using H. It's tan. So it's tan with the angle equals O over A. So root 50. 20 over root 50 over 2. So root 50 is 5 root 2. Half of that is 5 root 2 over 2. So we can use this answer in our calculator. And to get x by itself, we shift tan. So 20 over our answer. So shift tan 20 over our answer, and that is, so we've got 79.97, which makes it 80.0 degrees.